In this video, I'm going to try to teach you how to solve a quadratic equation by completing the square. This technique is going to seem a little bit complicated at first, and it is, but it's also the basis for understanding the quadratic formula and answering some questions that people had at the beginning about where the vertex formula came from. So I'm going to try and take it slow, and we're going to teach you this technique for solving any quadratic equation called completing the square. In order to complete the square, we're looking back for patterns that relate to expressions like this, x plus 2 squared. Well, let's think about first what this means. X plus 2 squared means x plus 2 times itself twice, because this exponent relates to this whole thing, times x plus 2. Well, that's x squared, x times x, plus 2x, plus another 2x, plus 4. We get x squared plus 4x plus 4. Another example of expressions like the x plus 3 squared, which is equal to x squared plus 6x plus 9. Let's do one more. X plus 11 squared is x squared plus 22x plus 121. Have you noticed the pattern in these results? That the middle term is always 2 times x times whatever the number is. That works. 2 times x times 2 is 4x. And 2 times x times 3 is 6x. And 2 times x times 11 is 12x. And the last term ends up being the square of the second term. And the first term is the square of the first term in our factor. Okay, well, we can use this to do some factoring. For example, if you had to factor the expression x squared plus 10x plus 25, and you notice that the first term and the last term are both perfect squares. In this case, the perfect square of x and the perfect square of 5. And the middle term is 2 times x times 5. 2 times x is 2x times 5 is 10x. Then you can take these two numbers, x and 5, and factor x plus 5 squared. What if you had x squared minus 14x plus 49? Well, again, the first term and the last term are both perfect squares. This is the perfect square of x, and this is the perfect square of 7. And the middle term, in this case, is 2 times x times 7, or almost. In this case, it's negative. What if I make this 7 negative? 2 times x times negative 7 is negative 14, and negative 7 times negative 7 is positive 49. So in this case, we can factor the expression into x minus 7 squared. This technique even works when you have more complicated expressions like 2x minus 3y. Oops, sorry. In this more complicated expression, we can still find the same pattern. The first term is a perfect square, in this case 10xy squared times itself would give you 100x squared y to the fourth. And the last term is a perfect square, 3xy. Well, if the middle term is 2 times 10xy squared times 3xy, then we know we have a perfect, what's called a perfect square trinomial, and we can factor it using our pattern that we've seen above. Well, 10x squared, 10xy squared times 2 is 20xy squared times 3 is 60x squared, y to the third. So this factors into, 10xy squared plus 3xy. Squared. Well, remember what I taught you about how to factor, making sure that your factors are fully factored. In this case, we could factor out an x, y from each of the factors. So we would have 10y plus 3, and all of that would be squared. But that's getting a little bit beyond what you need to know. Generally, for the purpose of being able to complete the square, you need to recognize when an expression like x squared plus 8x plus 16 can be factored because the first and the last terms are perfect squares. Square of x, this is the square of 4, and the middle term is 2 times x times 4. So we can factor this to x plus 4 squared. So then what does completing the square mean? Let's take an expression like x squared plus 2x minus 1 equals 0. To complete the square, we first just imagine that we had a trinomial that fits our pattern, where the first and the last terms are perfect squares. And the middle term is 2 times the square root of the first and the square root of the last. Well, in this case, we already have x squared, so I'm thinking the square root of this is x. But this last term, negative 1, is not a perfect square. So instead, to complete the square, I think about what this term would tell me. Well, 2 times x times what is 2x? Well, times 1. So x squared plus 2x plus 1 would be the perfect square. Well, if I wanted to replace this perfect square with this one, what is it changed by? Well, I've added a 1 to this side, but I still have this negative 1 here. I'm just going to keep the negative 1 over here. Have I changed the value of the original expression? Yes. And that's not okay to do in an equation, so I also need to add 1 to this side. And if I add 1 on both sides, it's the same as this equation that I began with. The difference, though, is that now I can take my equation and factor this part of it. This is x plus 1 squared. Well, I still have minus 1 equals 0 plus 1. That was a 0. And to solve this equation, I can add 1 to both sides. So I would have x plus 1 squared equals 2. Well, think about what we could do from here. To get x by itself, it's being added by 1 and then being squared. And usually to solve an equation, to get x by itself, we try to undo whatever's happening to x. So in this equation, we could first undo the square by taking the square root of both sides. On this side, I'd get x plus 1. And on this side, I get plus or minus the square root of 2. Well, from here, to get x by itself, I just need to subtract 1. So I get x equals negative 1 plus or minus the square root of 2. That's really two answers. It's x equals negative 1 plus the square root of 2, and it's x equals negative 1 minus the square root of 2. You can use your calculator to calculate these, and you should get something like x equals about 0.41 or negative 2.41. Let's look at another example of how to complete the square. To solve this equation by completing the square, remember that to get a perfect square trinomial, the first, the middle, and the last terms all have to be structured so that the first and last terms are a perfect square, and the middle term is twice the first times the last term. So in this case, the last term is not a perfect square. So we kind of ignore whatever's here, if it's plus 5 or minus 5 or whatever it is, and we just focus on the first two terms. And we can already tell that our perfect square trinomial would be something like x minus 2, because 2 times x times negative 2 is negative 4x. Well, if we think about what that is when we expand it, it's x squared minus 4x plus 4. We take this perfect square, we replace this part of the expression for this part, x squared minus 4x plus 4. Well, I ignored this at the beginning, so this is still over here, minus 5. But now we have to think, by how much did I change this expression? Well, it was x squared minus 4x to begin with. But now I've added 4 to this part. So, to make the equation balanced, I need to add 4 to the other side. So it was 0, 0 plus 4 is 4. What I can do now, though, is I can factor this part of the expression. X minus 2 squared. I still have this minus 5 equals 4. Well, to solve the equation, I'm going to add 5 to both sides. And I have x minus 2 squared equals 9. Now is the step when I'm going to take the square root of both sides. On the left side, I'm just going to end up with x equals negative 2. But on the right side, I'm going to get the positive and the negative square root of 9. Well, that's really plus or minus 3. So I add 2 to both sides, and I end up with x equals 2 plus or minus 3. This basically gives me 2 answers, because I have to do 2 plus 3 and 2 minus 3. So 2 minus 3 is negative 1, and 2 plus 3 is 5. So the two values, and the two solutions of this equation are negative 1 and 5. To complete the square here, the equation is not equal to 0 to begin with, but that doesn't matter. I can start by looking at the first two terms and just trying to decide, well, what would make this a perfect square trinomial? If it was x squared plus 6x plus 9, then it would be a perfect square trinomial, because 3 plus 3 is 6. So 2 times 3 times x is 6, and 3 times 3 is 9. So I added 9 to the left side to make it a perfect square trinomial. Well, I have to add 9 to the right to keep the equation balanced. Now on the left side, I can factor it to x plus 3 squared. From here, we take the square root of both sides, and we use the positive and the negative square root of 19. We don't write the positive or negative x plus 3 on the left, because we would end up with essentially the exact same answers as we would if it was just positive x plus 3. So from here, I'm going to subtract 3 from both sides, and I get x equals negative 3 plus or minus the square root of 19. Okay, I'm going to show you a couple more examples of some ways that we can complete the square, being a little bit trickier, but the basic gist is we look for the x squared term and the x term, and we figure out, we take half of the coefficient of x, and we square it to figure out what needs to be added. Let me try to explain that in the next example. In order to complete a square, we need the value that we use in the square to be half of the term, the coefficient of x. So in this case, I'm going to picture 1.5 is half of 3. So if I had x plus 1.5 squared, I would start with x squared plus 3x, and then the final term would be whatever I get when I do 1.5 times 1.5. Well, 2.25. So this tells me that I need to add 2.25 to both sides so that I can have a perfect square on the left side. Here's the plus 2.25 plus 1 again equals 0 plus 2.25. From here, I have a perfect square trinomial to begin with. So I can have x plus 1.5 squared. Then I have this plus 1 left over, so plus 1 equals 2.25. So subtracting 1 and taking the square root, I'd have x plus 1.5. Actually, I'll just subtract 1 at first. Equals 1.25. Now I'll take the square root of both sides. And then I'd subtract, remember the plus or minus square root. I have x equals negative 1.5 plus or minus the square root of 1.25. It's okay to leave your answer like this, or to actually calculate out the two values from doing negative 1.5 plus and negative 1.5 minus. Okay, the last example is what if there's a coefficient of x squared. We can still solve this by completing the square, but it's easiest to complete the square when our first term is just x squared, or rather 1x squared. So I'm going to start by dividing by the coefficient that I see of x squared. I'm going to do it on both sides to keep the equation balanced, and I end up with x squared plus 2.5x plus 3 equals 0, because 0 divided by 2 is 0. Well, from here, I can do the same thing I thought about before. What's half of 2.5? 1.25. If I squared that, I'd have x squared plus 2.5x plus 1.5625. So that tells me that I'm going to have to add 1.5625 to both sides. So I get x squared plus 2.5x plus 1.5625 plus 3 equals 1.5625. Factoring the first perfect square into x plus 1.25 squared plus 3 equals 1.5625. I'm going to subtract 3 first. And here I have x plus 1.25 squared equals negative 1.4375. Okay, well from here we take the positive and negative square root of both sides. We get plus or minus the square root of negative 1.4375. Okay, well, it turns out that negative square roots are not at least not using the numbers that we have. So because there's a negative square root, we'd have to say non-real answers or no real solutions. This actually relates back to those parabolas that didn't hit the x-axis. So this parabola might look something like that. Okay, well, I know this has been a long video, but completing the square is a pretty difficult technique, and I hope these examples will help you complete the square. Good luck.